I'm really excited to welcome our guest speaker today, who is Jerry Liu, the co-founder and CEO of LlamaIndex, one of the most popular and well-known frameworks for work with LLMs, and a key enabler to our work here at Samsara with generative AI. Jerry has a distinguished background both in software engineering and machine learning. Prior to LlamaIndex, Jerry led a machine learning team at Robust Intelligence. He also worked on self-driving AI research at Uber Advanced Technologies Group. And prior to that, he was working on recommendation systems at Quora. So a really interesting mix of experiences with AI at different companies on topics that are relevant to many of the kinds of products and use cases we're working at Samsara. And today, I believe Jerry's going to take us through a walkthrough of the LlamaIndex ecosystem with a particular focus on agents and multimodal data, also a highly relevant topic for Samsara. And so we're super excited to have you here, Jerry. And with that, I'll just hand it over to you.
Great. Yeah, thanks for the kind intro, Evan. And it's great to be here. Thanks for having me. And I'm super excited to kick off the presentation. If you want to do follow-ups after, happy to chat offline as well. We've tried with some folks on the Samsara team on a few different use cases. And of course, some of the feedback that you have helps inform our product roadmap. And so, happy to keep the back and forth conversation going. But yeah, just a quick introduction. I'm Jerry, co-founder CEO of LlamaIndex, and the talk title is basically on building a multimodal knowledge assistant. I will zoom in really quick. For those of you who aren't familiar with LlamaIndex, LlamaIndex is a company that helps any developer rapidly build production-grade agents and other types of applications over your enterprise data. And so we help take that from prototype to production. And we have two main product offerings. We have an open source toolkit, which is a developer toolkit for helping you build production applications of your data. This includes, RAG chatbots, agents, as well as, some of the use cases that we'll talk about here. And then also LlamaCloud. LlamaCloud is our managed service focused specifically on data processing, ingestion, retrieval. So really helping to create that data infrastructure for your LLM apps. We're very interested in this overall idea of building a knowledge assistant. And this overall idea of building a knowledge assistant is basically, we want to enable LLMs with all their reasoning capabilities to tap into basically everyone's enterprise data. And so how do we do that, right? And that's basically the architecture that we'll talk about during the talk. But the overall idea, right, the overall use case for the end user is that as a human, you're able to interact with this personalized assistant that has a complete view of both your user level as well as organizational data. It can, leverage the power of LLMs to basically take in any sort of input task that you give it, whether it's a simple question or it's a more complex research ask. And it can give you back some output, whether, again, it's like a simple chatbot response or something more sophisticated, like generating an entire report or performing an action for you. For those who followed our videos or Twitter, we talk a lot about the downsides of what we call naive or basic RAG. And a basic RAG stack basically consists of a lot of a basic RAG stack consists of the following steps, all of which could be made better. And so basic RAG basically means that you load in some data, you split it. So for instance, you load in a PDF or two, you split it according to some chunk size. You put it into a vector database, and then you do top K retrieval from the vector database to identify the most relevant context for the given task, and then you feed that context to an LLM to generate a response. Probably the biggest downside in this overall RAG stack is that you're not really leveraging the LLM for reasoning, and especially at the beginning. And so typically what we see is for a lot of users and basically for a lot of folks that are building RAG over their data, when they actually serve this as a product to the end user is only able to get back accurate responses over simple questions over their data. And so it's not really leveraging the capabilities of LLMs to actually help you, deploy a chatbot in a more scalable manner. If you have a lot of data, a lot of questions of greater complexity, this type of chatbot isn't able to actually fulfill that promise, right? If you think about just the overall interface of ChatGPT or Claude, one of the promises of LLMs is that assuming it actually knows stuff or has the right information, it can do a variety of different tasks of arbitrary complexity, like solve problems for you, search the web, perform actions, all these different things. And so the issue with the basic RAG stack is that it just simply doesn't have the right architecture set up to enable those more complex tasks to be fulfilled. And so along this point, right, we think that a standard knowledge assistant has like downsides both in terms of like the technical complexity, the technical architecture, but also this like translates into lower ROI for the end user. Like if you're trying to build like an internal ChatGPT for your users, and they realize that 50% of their questions are you're getting back hallucinated responses, then it's not actually helping them that much. There are time savings, decision-making enhancement, all the potential value adds of Gen AI are lessened because the overall technical architecture isn't able to support something that's a little bit more sophisticated. So the thing that we're very interested in is creating like the right technical architecture so that you can actually build a more production-ready knowledge system that delivers higher ROI to the end user. The one piece I didn't mention, and this feeds into the next section, is even before thinking about agents, the fact that the naive RAG stack typically makes very simplistic data processing decisions on this side means that even for oftentimes like simple search and retrieval questions, you're not able to get back the right answer over your data. And this motivates building, for instance, a multimodal knowledge assistant, where it's actually able to process the variety of different types of information that you have, whether it is within text or tables or images, or in the future like voice data and video data and other types of data too. So the 4 ingredients of building a multimodal knowledge assistant include, number 1, having a fundamental like high quality multimodal data processing and retrieval pipeline. We'll talk about that piece first because that's also at the core of what we do, really providing high quality components around data parsing, processing, retrieval. And before talking about something, the steps afterwards, and this includes complex output generation, being able to generate like kind of more complex outputs beyond like a standard chatbot response. So being able to generate like a report, performing data analysis, performing actions for you. Leveraging agentic reasoning to break down your inputs into like a set of steps. So, given some inputs, breaking it down through like query planning, tool use, and basically adding like that agent reasoning layer at the top of your RAG stack. And then 4, if we have time, we can talk about what it takes to build like something that's a scalable full stack application. I think for a few of these, I also have some notebooks I'm happy to run through. Basically showing you like concrete examples of how you can leverage components within the LlamaIndex ecosystem to help you build, different types of use cases and different types of use cases here. So the first step here is setting up multimodal RAG. I think this is a foundational piece of just making sure you have the right data architecture before you even thinking about like adding on different types of agentic tooling or capabilities. We care a lot about data quality, and we think that good data quality is a necessary component of any production grade LLM application. For instance, if you have raw data in the form of like PDFs, PowerPoints, Excel sheets, or from other data sources too, there typically needs to be this like general data processing layer, and that really is the first part of RAG, is like data processing, in order to transform this unstructured data into some representation that LLMs can access. And it's really this like new type of ETL stack for LLMs. So some of the components of this include parsing, so loading in your unstructured file and parsing it into the right representation. Number 2, chunking, or more generally like some sort of transformations on the source data to get it into some other format. Some of these transformation operations include like chunking. They also include like extraction, being able to extract out like structured data from your unstructured data. And then indexing, putting it into the right storage system. This includes a vector database, but this also includes other, components too. Like for instance, if you use a structured database, a graph database, there's actually a decent amount of complexity in figuring out, what storage system you use to actually represent the transformed unstructured data. All this stuff is important because if you had a bad ETL layer, if any of these components in the ETL layer were bad, then it turns out then the LLMs just don't have a good interface to access high quality data. And then no matter how good the LLM is, if your data is bad quality, then this tends to lead to increased hallucinations and bad quality responses. I think we mentioned this a few times during the Ray Summit talk as well, but we're very interested in a certain class of data, which is unstructured documents. We call there's a lot of these documents can be classified as complex. For instance, they have a lot of tables, they have charts, they have images, they have a lot of maybe weird fonts or irregular layouts. They also have headers and footers. Users tend to want to ask different types of questions over this data. And the issue is that, especially with the more traditional or naive RAG stack, if your components aren't very good, then users can't ask questions over this data. A lot of times, for instance, for charts or tables, they end up just getting ignored or skipped. We were actually talking to an enterprise developer, a user of LlamaIndex yesterday, and yeah, they were basically just saying, for a lot of stuff so far, we basically have just have told the users you can't answer questions over the charts, and they had a lot of almost product manual type documents with a lot of these types of diagrams and charts in them. And so this feeds into one of the core things that we build is really some core components around this that help you process this data, and so you can use it for your downstream application. And so the first thing I'll just showcase is, we have this feeds into LlamaParse, but basically, we think that you need a good document parser to basically process your unstructured files. This document parser ideally should be able to process your unstructured data into, into a set of sub elements with text, tables, and charts. It should be able to process tables accurately into relatively semi-structured and well-represented representations. It should be able to parse the text into semantically coherent chunks, and it should be able to extract out the visual elements from your document too. This is basically a LlamaParse. It's our advanced document parser. It's really good at processing PDFs, PowerPoints, stuff with a lot of tables, visual elements, and more. It's available both via API as well as via as part of LlamaCloud as well. And actually, that's probably one of the core, first demos I'll showcase is just setting up a multimodal RAG pipeline with LlamaCloud and LlamaParse in the loop to basically be a foundational layer for any sort of agentic application that you want to build. Even as just a core multimodal RAG pipeline, we see some pretty interesting use cases here. A lot of our users and customers basically use LlamaParse and LlamaCloud for a variety of different practical use cases across their complex data. This includes slide decks. That's a pretty popular use case. We're seeing some users basically use LlamaParse and LlamaCloud on top of slide decks have a lot of graphics. They have a lot of tables, floating text. 10Ks are a popular data source. So, financial reports, quarterly filings, every public company basically has to do this. Excel sheets is another interesting one. More on that in just a bit, but formatting the Excel and into some sort of markdown text, and instead of doing text to SQL over it, actually just stuffing it into the prompt of a language model. And then other domains and industries, for insurance, there's car accident reports. There's legal contracts, and there's different variations of these documents where you either have for instance product manuals with a lot of images, or it's some sort of form where you need to parse out the stuff in a key value pair format. This is just talking about assuming you have a good parser, it can parse out your elements almost in a document graph with text, tables, and diagrams. Then you can then do some sort of hierarchical indexing retrieval on top of this document graph. So instead of just doing naive chunking, where naive chunking just means you slice text into a bunch of different like equal sized chunks and then like index it into a vector database. Here you're doing something a little bit more hierarchical, like you actually extract out like multiple representations of the same underlying element. You index these representations, but then during synthesis, when you feed stuff into an LLM, you basically dereference these representations into the source element or the source, like the source text table or image to feed into the model. The extension here, right, like beyond a standard RAG pipeline and something that I imagine is maybe relevant to some like Samsara's use cases is like a multimodal RAG pipeline. A full multimodal RAG pipeline it's like an important component to basically help you like understand the text and also image data that's available within your documents. And there's so much you can do by just like kind of doing pre-extraction. Like if you somehow use the model and like a multimodal model and actually just like pre-extracted a lot of this text, the visual elements into text, then you can basically reduce it to like a text RAG pipeline. But there are benefits to just like preserving the document as like a native image chunk too. And so, we have built this both on the open source side as well as part of LlamaCloud. And the advantage of like, well, first I'll talk about like what the benefits are, and I'll talk about how it works. But the advantage of having something that's truly multimodal in nature is that you're actually able to do search and retrieval over both like with a deep understanding of the visual elements of the page. Like a really dumb question that you could ask that would demonstrate something that you can't really do with a text RAG pipeline is, what color is the bar chart, right? Like what color is this like bar chart right here of like the reinvestment rate? If you had a standard text pipeline, because you parse this into text, it probably wouldn't have retained the color information. No one would actually ask this in practice, but just like hopefully this is an illustration of an example where you're just preserving actually all the elements of the page. And so by preserving it as a both like text, but also image chunk, you can feed it to a downstream multimodal model. So this notebook, I can show the slides later on. It specifically goes through an example of parsing like a slide deck that has a bunch of these like charts and diagrams. And in the end, feeds it to a multimodal model, and then you get back a response. The overall trick, is to basically use LlamaParse. LlamaParse helps solve that like document parsing piece. It will screenshot each page for you, so you can actually get back image chunks. It will also, leverage some combination of multimodal models plus text parsing techniques to parse out stuff like this into structured tables. So then you get back both the text and the image. You concatenate them together, and then you index it into like a vector database. And then during retrieval, you feed stuff into a multimodal LLM. So like GPT-4o, 01, Sonnet 3.5, Gemini, more. Right towards the end of the section, I'll show you an example of this, but actually within LlamaCloud, because it's kind of more visually interesting because it's through a UI than through like a pure notebook. But before that, I'll quickly run through some other interesting indexing strategies that we've seen as well. One particular thing I want to highlight is just like GraphRag. I think there's a lot of interest in GraphRag, and I want to call it out because a lot of people are interested in it. There is maybe a little bit more hype than like oftentimes practical use cases sometimes, but at the same time, we are seeing a lot of companies with legitimate use cases for modeling stuff as graphs and then somehow tying that into the retrieval process. The overall use case that we see for GraphRag is it's basically an extension of RAG, where you like if you can somehow model your data domain into like an ontology, then it helps during the retrieval process, because instead of just doing vector search on specific chunks, you can also choose to traverse the relationships according to like the linked entities to pull in more chunks. So the idea of GraphRag, and really the way it helps, is it like will leverage prior understanding of like the ontology that you've created to just like pull in more context during retrieval. And conceptually, that should be better because basically the more context that like RAG or the retrieval part of RAG is able to pull in, the better the answer is. And so this is something that is supported within LlamaIndex. We have a bunch of abstractions that help. We collaborated with like Neo4j on helping users like both automatically build like a property graph over your data, your unstructured data. It will model like a set of like entities along with relations, and then every entity relation also has like the metadata attached to it. And then we have that tooling, and then we also have like notebooks implementing a variety of different graph RAG techniques. This is an example of like graph RAG from Microsoft, and I think this paper came out a few months ago, I would say, and kind of spurred some discussion within the community. But just to be clear, like this, they call this graph RAG, but it's just like a specific instance, like a specific way of like implementing it, right? Like I see graph RAG as a more general concept, but here, you go in, look at like specific text chunks, look at like community summaries, and then like summarize them. And then during retrieval, the retrieval process, you can actually fetch, like identify the relevant communities, and then pull in all the context within those communities to give back an answer. So we have an implementation of that. I realize I don't think it's linked here, or maybe I forgot, but basically, oh yeah, it's right here in the bottom. So if you're interested, feel free to check out those notebooks. I think we integrate with like Neo4j as a graph database. I'll show a quick demo of LlamaCloud in terms of what we're building in terms of like this enterprise RAG platform. Basically, it incorporates a lot of the multimodal RAG capabilities I just mentioned. And I think either way, we're basically we work with like different types of companies on like two levels. For a lot of companies, we engage with them on the open source. This helps us, it's like fun to do, helps us incorporate the latest techniques and feedback and basically get an understanding of what use cases like that developers are building for. And then for like not necessarily mutually distinct, but overlapping set of companies, we basically consolidate a lot of these best practices into like a managed service that we then provide to users to then pretty easily set up like a RAG pipeline over your data that is going to work well and scale in production. So just to give you a quick demo of this, and then I think I'm going to stop screen sharing for just a bit to just switch to my other window. But go here. This is an example of the LlamaCloud interface. And so, we, for instance, basically have like a UI where you can track a set of indexes or RAG pipelines over your data. And so just to give you a sense of what it takes to create an index, you basically give it an index name, select your data source. So you can choose between a variety of different like file-based data connectors. We've really optimized this for like unstructured data. And so, being able to like ingest a variety of different storage data sources that contain like unstructured files. So, you could also just choose to directly upload a file to this interface as well. The next piece is like you can configure the vector database that you want to use. We're looking at expanding to graph databases as well, given what I just said. But for instance, you can pick between a variety of different vector databases, and we support like 50+ databases on the open source side. You can choose your embedding model, which there's a few different embedding providers. Also, a lot of companies use like the big cloud vendors like Azure, Bedrock, and by AWS, and also Gemini. And then this piece is maybe an interesting thing to think about, which is, you can actually just toggle multimodal indexing and then different like parsing and transformation settings. And by toggling this just, we helped to make it like streamline this process. It will index everything as both text and also images. We will then make sure we parse the any sort of data you feed it in a structured manner. We will chunk it. You can configure like different types of chunking settings. And then the end result is you get back a pipeline that looks something like this. So I will show you that like ConocoPhillips slide deck, but basically in this created index, you basically have an API where you can do retrieval from it and fetch like relevant image and text sources. In the data sources here, you see we index this like investor report that we uploaded as a file. Going into this file right here, you can see that you have like a little PDF viewer where you can see the contents of this file. So for instance, like here is like a graph. Here's like more stuff, like 3 columns of information. Here's a table. You can see how LlamaParse is able to parse the text into Markdown. So for instance, for stuff like this, it's able to parse that table that I just showed into a Markdown table. And you can also see the chunks. So, the chunks right now are on the page level. And for instance, like if I scroll down to that same table, yeah, I think you can see the table is actually like rendered in the right layout. And there's metadata attached to every chunk. And just to give you an example of the end-to-end multimodal pipeline in action, right? Like I'm gonna just copy and paste this answer and put this in. We'll show that we can actually ask questions over like different parts of this slide deck that are actually just graphics. So instead of just like text, this is actually pulling its information from like a graphic on the page. So for instance, like here, when we ask about the different production bases that have kind of developed, it gives back the answer. And it pulls in both text and also images. But one of these, so here are text sources and here are image screenshots. And then here, you click into this node. Okay, it's broken. But basically, you're supposed to be able to see the screenshot of the page. Okay, it's unfortunate. Basically, you're supposed to be able to see a screenshot of the page, and it's in like one of the diagrams on the page actually. And so this information about like the different regions is actually represented in a graphic on the PDF. And you can also see the corresponding like text source as well. Like this is the result of LlamaParse being able to extract out information from this into a page. Cool. So that covers basically the multimodal RAG side. And so I'll go back into the slides, and then we'll talk about like the agent orchestration, because so far we've talked mostly about just how do you set up like a proper data pipeline. But the next part is just like going a little bit deeper into some of these use cases, especially in terms of like agent use cases and on top of this data. So agent reasoning over different types of inputs. We like one of the main motivations for adding in this layer of agentic reasoning is that in a standard RAG pipeline, it's optimized for, again, like standard search and retrieval questions. But one of the promises of agents is really being able to resolve very complex tasks. So for summarization questions, comparison questions, multi-part questions, research tasks, it tends to be a little bit less good for that because, for search and retrieval, like, if you think about the operations in RAG, you're doing vector search. It's inherently going to find the most relevant context to the question that you ask. So it's best suited for stuff where it's very targeted. You have a very targeted input because then it can find the relevant context that matches your input. But for some of these like more complex tasks, you want to basically somehow translate these complex tasks into a set of operations against your data interfaces. And that intermediate layer is basically an agent reasoning layer. And so, there's a variety of different types of ways you can build agents. There's more constrained agents. You can leverage like a few different ingredients like routing, tool use, query planning. And then there's also like full agentic architectures like React and like Tree of Thought and like LLM compiler and a few different just like full systems where you can give it like some input and it can behave relatively autonomously. There's trade-offs in terms of cost, latency, and performance. Full architectures here will be able to be more flexible and potentially more generalizable to a lot of different tasks. But they also tend to be more expensive and potentially less reliable. And so the way we think about like, again, our whole mission as a company is, build agents over enterprise data. So we think about things as like a progression, right, of like a set of tooling. you start off with the base. Let's say you're using some advanced modules to basically build your core multimodal RAG pipeline. In adding this agent reasoning layer, it's really about just like interfacing with your core RAG as a service, or your structured SQL database as a service plus other tools. And you're basically just like interacting with these other interfaces as tools. And I think that's a pretty powerful paradigm to have, which is like, you imagine you have some like system, and the system has some like capabilities of reasoning. It's able to take in an input and process it, and then it has some way of like communicating externally. And these external interfaces could be other agents, or it could just be like just tools that this agent can use, similar to like a human going to Google to like look up information. Here it's like an agent, again, given some observations or some inputs, right, like text or visual data, can then decide to perform actions by leveraging external services to help it. It can have internal like modules too. For instance, it can have like internal memory that it stores and updates over time, but it inevitably like needs to look up and interact with other services to update its own state and also perform actions. So like there's, and I'm sure this is maybe relevant for folks that are building like different types of agents, but we see basically like a variety of different types of agentic applications. And there's both like constrained flows as well as more unconstrained flows. First of all, like what is the overall definition of an agent? No one really knows or agrees on the right definition. And I have a very general definition of this, which is basically an agent is just like any program that has non-zero LLM calls. So more like one or more LLM calls in the loop, right? And if you accept that definition, which you might not, but like if you accept it, then there's an entire range of different types of applications, ranging from something that's a little bit more constrained to something that's very unconstrained. Something that's more constrained is basically something that has like fewer LLM calls, and instead has like the human basically defining a lot of the control flow and logic. So like, for instance, if you're not actually trying to let this agent do a ton of decision-making, you as a programmer can insert a bunch of like if-else statements, while loops, and maybe use the LLM to make like one or two decisions in the loop. For instance, like routing to route between like RAG and SQL, and do it once, but then you define like the rest of the flow for how it should go after this happens. An unconstrained flow would be like, instead of you as a programmer actually defining most of the flow of like how the program should execute, you're basically trying to let the agent figure it out at most of the steps of the way. And so like you're not really defining like an explicit pathway to like, or fewer places where you're defining explicit pathway. But for instance, like given some sort of task, should the agent use like this tool first or this tool or this tool? Like, who knows? Basically, we'll have some general agentic architecture where it'll take in an input and then try to dynamically reason about which pathway to take. And this might actually be task dependent. It might actually change depending on what the task is. And then, give back the response condition on the input. This again is more of the responsibility of like a general agent architecture, and has like nice properties to it. And I think like over time, things will probably like people will be more and more comfortable with like using these types of architectures to solve like different types of tasks. But at the moment, they tend to be a little bit more expensive, less reliable. An example of something that is unconstrained would just be like the OpenAI Assistance API. Like it's a very high level API. You're not really telling the agent what to do. You're just giving it a set of tools, and then just given any task, just let the agent figure it out. And that's basically an example of an unconstrained flow. At LlamaIndex, we're going all in on agents. And so we think an agent orchestration framework should have the following properties. The foundational units of an agent is what we call like a workflow. I'll show you what it looks like in just a bit, but it is very, very simple. It is intentionally designed to be super low level. And on its own, it doesn't actually do anything LLM related under the hood. basically, it's just an event-driven orchestrator, similar to temporal, kind of. But if you're familiar with like Airflow, temporal, Dagster, etc., it's basically a way of like kind of like executing some set of steps, and then like in our case, like passing events from one step to another. We designed this to also be very composable. So if you define like an agent as a workflow, you can piece together like a granular workflow into higher level workflows. So you can have like task specific agentic workflows, and then combine them together into like a higher level agent orchestrator, so on and so forth. It's designed to be very flexible. So I think if you look at, for instance, like CrewAI or AutoGen, they are great agent frameworks. They also tend to be a bit higher level, right? They have like a entire concept of like an automata, like an agent, basically, where you can give it like a system prompt and that type of thing. For us, like the base foundation it's just a Python class, and you can literally write whatever you want in the Python class. It's also code. It's so it also is meant to have a few other properties, like it should be easy for you to do stuff like human in the loop, for it to be able to manage state over time, so you can track that. It integrates well with like observability frameworks, so we have a few like different LLM observability partners that we're pretty close with, and then it should also be easily deployable in production. I'll give an overview of what this looks like, but basically, I think the comparison point would be something that's a bit more graph-based. There's LangGraph. There's also our own like deprecated like query pipelines, which we used to have as like a graph-based orchestrator. I think the main thing is, and this is in the end up to you, and we're actually super open to feedback on kind of like the ergonomics of this stuff, is one thing we found a little bit awkward about the graph-based approach when we were actually iterating on our own like query pipeline syntax is you spend a bunch of time like writing like graph code. Basically, it's like you spend time like adding modules to this graph, and then also baking in the orchestration logic in the edges. And so it ended up becoming a little bit cumbersome to write, and oftentimes a little bit harder to debug without the help of like an external debugger. Whereas here, the idea of a workflow is it's very much just like a class with like a set of steps. And every step, this actually isn't the right syntax, but basically takes in some input and emits some output. And I'll show you that in this notebook right here. This notebook right here that I'm about to show basically combines that with the next section, which is on report generation. So this is basically a multimodal report generation agent. I will show you this real quick. And the goal is to, index first, like set up a RAG pipeline over some bank of papers. Here it's like papers from iClair, right? Like the deep learning research conference. And so we want to basically, take in a user task and then basically generate a report given that bank of papers as context. Here, this is just like an example of like indexing a bunch of PDFs. We index these PDFs with LlamaParse. I'm going to skip this entire section of code, but the idea is we basically build a multimodal RAG pipeline. I think anyways, we basically like all this code right here is just building a multimodal RAG pipeline so we can query the papers, like the PDFs. And this will have an understanding of both like the text as well as like the charts and figures within the PDFs. Next, we're going to go to the workflow section, which I think is maybe an interesting illustration of like how you can build like a simple workflow. So we're building what we call like a report generation workflow. The goal is to do two things. Well, first is like research gathering. So the agent, the user submits a task, like I want a report about like fine-tuning techniques, for instance. We'll do a research gathering step where the agent tries to reason about, how do I like use my RAG tool to pull in the right information, and then iteratively do research by pulling in, doing retrieval on top of that data, and then putting it into, for instance, like a vector database. And so this will kind of continue to do call the RAG tool on a chain of thought process to pull in research until it feels like it's pulled in enough information into like a central dictionary. Step 2 would be, once it feels like it's done enough, we'll generate a research report given this pooled research. And this, honestly, like this step is kind of dumb right now. We're working on like making it better, but it's basically just like, given, all the research that you have, stuff it into the context window of an LLM and generate like a structured output. And the structured output, you can see the schema right here. It looks something like this. The output contains both image blocks as well as text blocks. And so this is basically a schema defined as a Pydantic model. And you give this to the LLM so that it generates the outputs according to the schema. Most LLMs these days support function calling now. And so because they support function calling, you're able to like feed in schemas like this for them to generate over. Here's also like the system prompt, your report generation assistant tasked with like producing a report. And then, please generate a report with like interleaving text and images. So here is where you actually get into the place where you like define a workflow. And you can see like what a workflow actually looks like. So ignoring the imports, a workflow is basically a base class that we subclass from. It's a Python class, basically. You can put whatever you want in the initialization function. And a workflow basically contains a set of steps. You can see every step here is just a Python function. You can see it's a fully async Python function. The signature of every function takes in some context and some event, and then it emits an event. The context is just the state management. You can store different things in the state. We will, I think we have, I forgot, but actually I think we have options maybe to like store that in some sort of like persistent storage, or at the very least, like it's attached to like a user session. So you can have like multiple users on the same workflow. And then here is like an event. An event is basically just like a Python class that you define. It can basically be like a blank class, but it can also take in an arbitrary set of like inputs. And then, so it takes an event and it emits an output event. And your entire responsibility in defining a step is just writing what happens, right? Writing the steps to process like an input event and produce an output event. So in this setting, like you can see there's like a few different steps. First, the start event is like the very first event that gets emitted on user input. We are just going to prepare like the chat message, like the user chat message, and put it into the memory. That's basically all we do in this step. The next step here is to feed the chat history into the LLM with the set of tools, the RAG tools that are made available to it. And then you're basically just checking, given this chat history, the system prompt, are we actually done, right, in terms of the research step? If the tool calls is non-zero, this means that we want to continue emitting like a chunk and document level retrieval event. And then, it will continue to feed back into this, or it will feed into this next step, which will do document level retrieval, and then go back into this step. If it is done, so there are no more tool calls, then it will emit like a final report generation event. So obviously, you can have like two steps pass events back to each other. You can have like cycles basically implicitly due to this like message passing nature. And the goal is like within every step, it's modular, and you just define like what outputs that you want to attach to it. There is also a variant of workflows where you don't need to define a Python class. You just define like a set of Python functions, and then you can just combine these functions together into like a workflow. I think it's up to you. I think this allows you to manage kind of like core state a little bit easier through like initialization. So we built this report generation agent. It's emitting a ton of different events. And then, we're going to ask, help me generate a report analyzing these different experimental techniques. And you can see the like simple trace that it emits like in the logged output shows what it's doing. It's like the input event is just the user ask. it's performing some basic retrieval from the RAG tool to search for, the paper where it's talking about this technique. It's pulling that in, and then it's generating a report. Right? And then here is like the final response that it renders when you get back the output. You can see it's not quite interleaving, but it basically gives you back a bunch of text, right? So it's feeding the context in, it's generating the output here. And then it's also feeding in, we have like the image screenshot as like a source. We're working on like more fine-grained image segmentation, so you can actually, like screenshot like specific pieces of the images as opposed to just the entire page. But in the meantime, here we're just like, dumping the entire page as part of the output. And then I think there's also a way to draw the execution, which, because I didn't run this, I'm trying to see if there's ways of just like showing you this, but basically like you can see an entire like execution graph of how this runs. This integrates with observability tools. So we integrate, for instance, with Arise, where we call it LlamaTrace. It's basically a collaboration with them, and you basically get back like a hosted execution, like observability platform. I think I know we also integrate with like LangFuse and other tools out there. So going back into this, I showed a basic notebook flow through like a workflow that does report generation. So it combines both, some of the core data indexing capabilities along with the workflow orchestration. And then the last piece is basically just like, running an agent in production. And there's basically three main pieces here. And I'll try to wrap this up, but the first piece is, so you wrote your workflow. Now you want to deploy it. And we have an open source project called Llama Deploy, which helps you deploy your agent workflow as a set of microservices. This basically contains like an API interface that you can, a high level API server that you can basically that can serve requests, that can serve like different types of client requests. And every agent is basically modeled as like a separate API and microservice basically under the hood with its own ports. They can communicate with each other through like a message queue. In this case, like an agent, if you use workflows, is basically like your own workflow. So if you have, a set of different workflows, composed workflows on top of each other, all these are modeled as separate API endpoints. And then they communicate with each other through some message queue, which can be implemented, as like Kafka or RabbitMQ. And then we are working on having human in the loop, for instance, as a service. And then you can also deploy this easily onto like a Kubernetes cluster. And we have like templates that help you do that. That's on the deployment piece. And then the other pieces, I figured, I don't have like a live demo. I just share with you, but we have actually some pretty cool full stack templates to basically just like help jumpstart whatever application you're building. And they're actually kind of underrated because we haven't promoted it as actively on our socials, for instance. But one example is Create Llama. And Create Llama is basically you basically just run one CLI command. And it's kind of like create React app in React. But you run this CLI command and you can basically, I think it's running, just select between like a set of different options, like what do you want to use, a fast API server? Like, do you want to set up like what model do you want to use, specify your API key. After going through some like command line options to define that template, it spins up a full stack application for you. And so it's honestly like, this is just an example of a spun up like full stack application where it's actually doing that report generation use case, I think. And it's like able to, like generate like an entire blog post given some, like you can see like a researcher or writer step. And it's basically, it's like a code template, right? So it's fully open source. You can customize it if you want after, but if you don't want to, you basically get back like a fully agentic system you can start using. Another example is something that we don't technically own, but our core contributor to Create Llama basically has as his own like independent project, but it's called RAG app. And it's basically like a no-code way of setting up multi-agents as a service. You can see here on the UI, instead of you writing code, you can just like, click a few buttons and configure like a different type of agent, like Crew AI style. It's obviously backed by some of the core workflow abstractions that we have within LlamaIndex. And then here, once you've set up these agents, you actually spin up like your own agent interface, similar to Create Llama. And then you can analyze the steps within each one of them, look at the tools they're calling, and chat with it. So this is also fully open source. So if you're interested, yeah, feel free to check it out and start using it. That's basically it. I didn't have too much more, but yeah, I think there's some questions in the chat, but happy to run this however you want to go.
Awesome. Thank you so much, Jerry. Great presentation.